Hello everyone, today we are going to be solving a question on integration. So here is our question as on the paper, which is x squared plus 3. The integral of x squared plus 3 divided by x cubed plus 2x dx is, okay, let me just take it back, right? Don't pause it. Are we there? I'll cut that part out. Hello everyone, today we are going to be solving a question on integration. The question says we should find the integral of x squared plus 3 divided by x cubed plus 2x dx. So now we are going to see that this particular function or fraction is quite complicated to integrate directly. So we have to express it in a form that is quite simpler for us to integrate. So we would have to express this fraction as x squared plus 3 divided by x cubed plus 2x equals x squared plus 3 divided by x into x squared plus 2. So what we just did was we factor out x to bring it in a form that we recognize. So what we are going to be doing is we are going to be breaking this fraction into its partial fractions. So that is what we mean by breaking it into simpler fractions that will be easy to integrate. So we have that the denominator of this fraction consists of a linear factor, which is x, and an irreducible quadratic factor, which is x squared plus 2. Now irreducible because we cannot factorize it, or we cannot have two linear factors out of this quadratic factor. So therefore we are going to be expressing this fraction as x squared plus 3 divided by x into x squared plus 2 equals sum a divided by x. Now a here is a constant. Now the reason is because the numerator, the degree of the numerator has to be 1 less than that of the denominator. So the denominator is linear, and so the numerator has to be a constant, plus bx plus c divided by x squared plus 2. Now the numerator is linear and the denominator is quadratic, so it follows from what we said earlier. So we are going to be solving for the constants a, b, and c by the cover-up method. So solving for a by the cover-up method, we have that we are going to go on the left hand side of this equation, which is here. We are going to mentally remove this linear factor x, or we are going to cover it with our finger like this, and then we are going to substitute x equals 0. Now the reason is because we simply set this linear factor x equals 0. That is a equal to x squared plus 3 divided by x squared plus 2 at x equals 0, which equals 0 all squared plus 3 divided by 0 all squared plus 2. So therefore our a equals 3 on 2, because 0 all squared is 0 plus 3 gives us 3, and 0 all squared is 0 plus 2 gives us 2. So our a equals 3 on 2. Now similarly we are going to solve for b and c. Now we are going to go on the left hand side of this equation. We are going to cover up the factor associated to bx plus c, which is x squared plus 2 in this case. So we are going to cover it up with our hands or our finger, and we are going to have that bx plus c equals x squared plus 3 divided by x at, now we are going to substitute x equal to root 2i. Now why root 2i? Because we simply set this irreducible quadratic factor to 0. That is, we set x squared plus 2 equals 0. So x squared equals negative 2, and taking square root on both sides, we have that x equals plus or minus square root of negative 2. Now this is a complex root, so in that case we are going to express it as in terms of complex root. So we have that this will be equal to plus or minus square root of negative 1 times 2, which equals plus or minus square root of 2 times square root of negative 1. And negative square root of negative 1 is what we call I. So x equals plus or minus square root of 2i. Now we are going to be taking the positive root, which is positive square root of 2i. Now we have that anywhere we see x, we substitute it by root 2i. So we have that b into root 2i plus c equal to root 2i all squared plus 3 divided by root 2i. So this boils down to root 2bi plus c equal to, now root 2i squared is the same as root 2 squared times I squared, and you know that I squared is negative 1 and root 2 squared is 2. So we have negative 2 plus 3 divided by root 2i. So we have that root 2b all I plus c equal to 1 over root 2i. Now we notice that the left hand side is in the form ai plus b, that is the left hand side is in the form ai plus b. So we have to make the right hand side the same, and this way we are going to remove the third at the denominator by rationalizing the denominator. So we are going to multiply numerator and denominator of the right hand side by root 2i to remove this third. So we have that this equals root 2i divided by, that's root 2i times 1 divided by root 2i times root 2i, and we have that root 2i times root 2i is equal to root 2i squared, which gives us negative 2 like over here. So we have that root 2i times 1 gives us root 2i, so which equals root 2i divided by negative 2. So we have that root 2b all I plus c equals root 2 negative root 2 divided by 2 all I. So we see here that we can make the right hand side look just like the left hand side. So we have that root 2b all I plus c equal to root 2 into negative half all that I, such that we are going to equate components at this level. So we have that root 2b equals root 2 into negative half, and we have that c equal to 0 because 0 here plus this on the right hand side, this term on the right hand side changes nothing, so obviously c equals 0. So we are going to divide both sides here by root 2. So divide here by root 2 where root 2 cancels, so we have that our b equals to negative half, so and our c equals 0. So we have that, therefore our fraction x squared plus 3 divided by x into x squared plus 2 equals, now we have that our a was 3 on 2 as above here, so we're going to have 3 divided by 2 times x, which is 2x. Now we have that our b is minus half, so it's going to overwrite the positive sign here, so we're going to have minus x, so our c is 0, so it changes nothing, minus x divided by 2 into x squared plus 2. Now this is just the first step we have taken. We have broken down this fraction into much simpler fractions where we can integrate. So we're going to go ahead to integrate these fractions, each one. So now we have that the integral of x squared plus 3 divided by x cubed plus 2x dx is equal to, or is equivalent to, the integral of 3 in the original expression. So we have that the integral of 3 divided by 2x dx is the same as 3 over 2 the integral of 1 over x dx. This is so because the integral sign actually factors out constants. That is why we have 3 over 2 out here times the integral of 1 over x dx. Now we know that the integral of 1 over x dx is equal to the ln of the absolute value of x. So the integral of 3 over 2x dx will be equal to 3 over 2 times the ln of absolute value of x. Now let's go on to integrate. The integral of x divided by 2 into x squared plus 2 dx. So the integral of x divided by 2 into x squared plus 2 dx is equal to, we factor out half times the integral of x divided by x squared plus 2 dx. Now we see that the numerator here is the near derivative of the denominator. So we're going to differentiate this a little bit differently. So the derivative of the denominator, which is x squared plus 2, the derivative is 2x. So we are going to play around with the constant 2 to make the numerator the exact derivative of the denominator, so that it will be easier to integrate. So we have that we are going to be multiplying both numerator and denominator by 2. So we have that half the integral of x divided by x squared plus 2 dx is equal to half the integral of 2 times x divided by 2 times x squared plus 2 dx. So we are going to factor out these 2 here at the denominator to give us half times half, and the integral of 2x divided by x squared plus 2 dx, which gives us 1/4 the integral of 2x divided by x squared plus 2 dx, so which gives us 1/4 the ln of the absolute value of x squared plus 2. So we have that, therefore the integral of x squared plus 3 divided by x cubed plus 2x dx is equal to, we have our first integral which we resolve here, which is 3 over 2 ln absolute value of x minus 1/4 ln absolute value of x squared plus 2 plus some constant k, which is called the constant of integration. So thank you very much for your keen attention. Hope this solution helped, and do not forget to subscribe to the channel. Ciao.